that reminded me of something that was presented actually in this room 2 years ago by Professor Cohn from UCLA when he did his environmental assessment of cancer in the community. And he showed, this is centered on Santa Susana, the prevailing winds. This is called a wind road, so you can't see the title at the top. But what it shows is that the prevailing winds run southeast and northwest. And this southeast sector, where the prevailing winds were going from Santa Susana, seemed to reflect to me what I was seeing in the map that I showed you just earlier. So I was starting to sort of put some things together and ask some questions. And basically this raised some questions in my mind, at least when I started talking to people in the community. I wanted to know, for example, how many cases of retinoblastoma occurred in Los Angeles and Ventura counties in the past 2 decades. Were we just seeing, were these the only 9 cases, or were there more? And where do they occur? Did those cases cluster in space or time in Los Angeles or Ventura counties, like I was seeing? I must say that, remember that retinoblastoma, at least statistically, is a very rare event. And if the rare event were occurring randomly in the population, it wouldn't look evenly distributed. You would see clusters. So clusters occur by chance. And so that's something you have to be very cautious about when you investigate this. But when I saw those 5 cases clustered so close together in such a rare disease, something that occurs in only 5 to 7 out of every 1,000 live births, it made me think that there might be something more than chance, especially when that cluster seemed to run in that southeast sector away from the Santa Susana Field Lab.
To go back to Sheila Kuehl's bill, which would, if successful, would raise the standard of cleanup at the laboratory. For years, the community members who have been pursuing higher standards of cleanup have called for it to be designated as an EPA Superfund site, because Superfund status would give it the highest required cleanup levels. And for years, the answer has been no, it doesn't qualify. And that answer was based on small studies that looked at certain areas. About 2-3 weeks ago, EPA came out and said that they will now go back and look at the entire 2,800 acres to see if it qualifies as a Superfund site, which is huge. They went from looking at very small, tiny areas, now they're going to take a look at the entire area. That combined with some of the legislation that has come forward, though has not been passed yet, I think we're really seeing a turning of the tide in terms of the focus that's being put on this facility and the cleanup levels. At the same time, you have the Department of Energy, which again is in charge of the cleanup of the nuclear radiation that its predecessors created there, moving forward with its cleanup of the last 2 facilities in Area 4, one of which is the Radiation Manufacturing Handling Facility, RMHF. And they recently had public scoping meetings to get public comments. There was concern among community members that this meeting wasn't publicized enough and that it had small turnout. And one of their cleanup projects, they did extend the period for comment. And in response to the lawsuit that was filed by the Committee to Bridge the Gap, the NRDC, the City of Los Angeles, which the Department of Energy lost, the comment so far is that they're still reviewing the results of the lawsuit. That lawsuit, the judges ordered that they go back and reevaluate their standards of cleanup for it. So you have sort of this critical mass of activities that is happening.
So how do we assure that what remains in the soil and in the bedrock is safe? What's the health-based risk criteria? Now, those of you who've been coming to these meetings before will remember that we have in the past used a 15 milligram per year dose limit, which is typical of what is used, for instance, by the NRC and the rest of the Department of Energy and many of the state radiological organizations. 50 milligram was determined to be a safe limit. We have decided for these last two buildings to switch to the circular approach, and therefore this is the objective, which is in the ECA, and the objective is to lower the excess cumulative cancer risk due to an individual from exposure to SNAP contaminants in the soil to a nominal range of between 1 times 10 to the minus 4 and 10 to the minus 6, which is between 1 in 10,000 risk and 1 in a million risk, using 10 to the minus 6 as the point of departure. Now, what does point of departure mean? It means that we will strive to detect all the radionuclides at this risk level, and we'll see in a later chart. I'll give you the soil concentration limits which are applicable to these two ranges. So we will strive to meet that. We will certainly meet the range, and that will be documented and presented to the public in the meeting. So what are the constituents of concern, or the contaminants of concern that we're looking at? I've described that the primary radionuclides that we found in the concrete are europium-152 and cobalt-60. So those are the primary things that we'll be looking at in the soil and the bedrock. However, we recognize that all these other isotopes are typically generated in any nuclear reactor. The typical fission products, for instance, are cesium and strontium. The other neutron activation products include helium, europium-154, iron, nickel, manganese, and sodium-22. Now, we've included also potassium-40 here. Now, that's a naturally occurring radionuclide, which we'll talk about later on. The coolant in the NAC reactors was, the coolant in the SNAP reactors was NAF. It's an alloy of sodium and potassium. Now, the regular isotope of the potassium is potassium-39. If it absorbs a neutron, it can generate a potassium-40 and therefore potentially increase the normal levels of potassium-40. So we're also looking for that. We'll also look for all the nuclear fuel material which was in the reactor, the different isotopes of uranium, and we will look for all the transuranic elements that are potentially generated during the nuclear process, including americium and all the plutonium isotopes. These are all the constituents of concern that I listed on the previous chart. This column is the concentration in soil in terms of picocuries per gram, which is equivalent to the 10 to the minus 6 risk goal. That is the EPA point of departure. These are the corresponding levels which are corresponding to the EPA's 10 to the minus 4 risk level. So remember, CERCLA has a risk range which we need to achieve. EPA have stated that achieving anything in the risk range is fully protective of public health and environmental health. So, for most of the isotopes, almost all of these isotopes, one can achieve these kind of levels. Now, there are two technical problems one has to overcome in achieving those levels. The first thing is that the radiochemistry lab that you send the soil samples to needs to be able to detect isotopes at those levels. Now, for most of these, they can readily detect levels below these kind of levels. Some, there'll be a little bit of a challenge. For instance, europium-152, getting down to 0.04 may be a little difficult. One will have to increase the count time. Some, like naturally occurring potassium-40, if one is to achieve 0.1, that may be a little difficult for a radiochemistry lab.